Today's the first lesson of geometry, and we're going to be focusing on points, lines, and planes. Before we begin going through the note sheet, I'm going to switch to a video. It's a math antics video. It's not something I have made. And this video has really nice graphics and explanations of the topics that we're going to be talking about over the next two classes. So if you could follow along with this video, we'll come back together and we'll look at the note sheet in just a moment.
Hi there. Today on Math Antics, we're starting a new subject where we're going to learn the basics of a special kind of math called geometry. Geometry is the study of things like lines, shapes, angles, distances, and things like that. In this video, we're going to focus on three of the most basic elements or parts of geometry. They are points, lines, and planes. All right, we're going to start with points because they're about the simplest thing you can imagine in geometry. What's a point? Well, let me draw some for you. So these are points. They're just little tiny dots in space, but they do a really important job in geometry. They help us describe specific locations in space, like the end of a line, or the corner of a square, or the center of a circle. But they won't really help that much unless we name them, because if I say, hey, look at that point over there, it's kind of hard to tell which one I'm talking about. I mean, they all look the same. So what name should we give these points? Well, let's see. How about Archimedes and Beauregard? That'd be good. Maybe Charlemagne? How about Daphne and Einstein? Let's see. Fred and Guinevere, Hiawatha, and Icarus. Perfect. You know, on second thought, those names are kind of long and complicated. Why don't we just use the first letters of each name instead? There. Now if I say, look at point A, or look at point B, you know exactly what I'm talking about. In fact, let's do that. Let's just talk about point A and point B for a minute. If you start at point A and go to point B taking the shortest distance possible, you would have gone in a straight line. A line is the next most basic element of geometry. We name a line by the points that it goes through. For example, we would call this line AB because its endpoints, where it starts and stops, are points A and B. But technically, this isn't really a line. It's a line segment. What's the difference, you ask? That's a good question. A line segment has a beginning and an end. It starts at one point in space and it ends at another. A line, on the other hand, just keeps on going in either direction forever, just like the number line keeps on going forever. Well, at least we imagine that it goes on forever. We can't actually draw a line that goes on forever, so here's what we do instead. To draw a line instead of a line segment, you just go past the endpoints a little bit, and you put an arrow on both ends of the line to show that it keeps on going. So this is line segment AB, and this is line CD. Now there's one more special type of line that we need to talk about, and it's basically a combination of a line segment and a line. We call it a ray. Rays have beginning points, but no ending points. They just keep on going forever, but only in one direction. So we only put an arrow on the end that keeps going. There. We call this one ray EF. In geometry, each of these three types of lines has a shorthand way of writing it. Instead of writing line segment AB, you can just write AB with a line over the top. And instead of writing line CD, you can write CD with a double arrow line over them, like this. And finally, instead of writing ray EF, you can just write EF with a single arrow line over them, like so. Okay, so now you know about points, and you know that you can form a line between any 2 points. The next thing we're going to learn about is planes. No, not the kind of planes that you fly in. Now, to help you understand how planes in geometry work, let's go back and look at all those points that we had at the beginning of the video. It looks like all the points are the same depth on your computer screen, right? And if they were, we'd say that they're all in the same plane. And that's because your computer screen is a plane. It's a flat surface like a window or a sheet of paper or a tabletop. A plane or flat surface is what we call a two-dimensional object because there's 2 dimensions that you can move in. You can go up and down, or you can go left and right. A line, on the other hand, is a one-dimensional object. If you're on a line, like line AB, there's only one dimension that you can travel in. Sure, you can go forwards or backwards along that line, but it still has only one dimension. You can't get to point C without going off of line AB. But if you're on a plane, a two-dimensional object, then you can get to point C, because point C is on the same plane as points A and B. All three of them are on that flat two-dimensional surface, which is your computer screen. Cool. So that means that if I want to get to point D, I can do that too, because it's on the same plane as A, B, and C, right? All right, I have a confession to make. I tricked you. Point D really isn't in the same plane as the computer screen. It just looks like it from the position you're viewing it from. Watch what happens if I start rotating the screen space a little bit. Aha! Now you can see that the points are actually scattered all over the place in space. Point D is actually in front of the plane that A, B, and C were in, along with some of the other points. And the rest of the points are actually behind the plane that A, B, and C are in. What we have here is a three-dimensional space, or 3D space for short. In a three-dimensional space, there's three dimensions you can move in: left to right, up and down, and in and out. If we're on the plane that contains points A, B, and C, we can't get to point D unless we leave that plane by traveling in that third dimension. A three-dimensional space like this is often called a volume, but we'll talk all about 3D volumes in another video. For now, let's get back to talking about planes. Earlier in the video, we learned that you can make a line by connecting any 2 points, right? Well, in order to make a plane, it turns out that you need to have 3 points. Like our 3 points A, B, and C. If you just connect A and B, you get a line. But if you connect A, B, and C, you get a triangle. Now you're probably thinking, wait, I thought we were supposed to get a plane, not a triangle. Well, because it is a flat surface, a triangle is a lot like a plane, but it has 3 edges. It stops and doesn't keep on going forever. When we were talking about lines, do you remember how a line segment had endpoints, but a true line kept on going forever? Well, it's kind of the same way with triangles and planes. You could think of a triangle as a smaller part or a segment of a plane, but the plane itself keeps on going forever. So 3 points is all it takes to define a plane. And in the space we've been looking at, we already have plane ABC. So let's try making some other planes with the rest of the points. We can choose any 3 points that we want to. Let's join D, E, and F. Now we can see the triangle they form, and if we extend that flat triangle, we can see the plane that it defines. Let's try one more so the rest of the points don't feel left out. Let's join G, H, and I. There. Now they form this triangle, a flat surface that forms this plane if we extend it in every direction. So now you know about planes, lines, and points, 3 basic elements of geometry. There's a lot more geometry ahead in upcoming videos, so stay tuned. And you can check out the exercises for this section. They're pretty easy and they'll help you remember what you've learned. Thanks for watching, and I'll see you next time.
Okay, so now that we've seen the video and we've hopefully understood what points, lines, and planes are, I'm going to take a moment and just quickly go through our undefined terms. You have this typed right on your note sheet and it was just explained to you, so I don't think we're going to go through every part of it, but we'll briefly go through each example. So looking at points, here's my example, which is just point A. So I labeled one single point and you name it with a capital letter. There I labeled it as point A. Lines are made up of infinitely many points. Lines extend in both directions forever. You indicate that you have a line by putting an arrow on each end. Lines can be labeled in multiple different ways. So the first method is to label a line by labeling it with 2 points on the line and using the line symbol above it, such as AB. You could also name this line AC because the line cuts through both points A and C. You could label it BC. You can switch the order of these points. So instead of labeling it, for example, AB, you could label it BA. Okay, there's multiple different ways that you can use 2 points on the line and use them to label it. The second method is by using the single lowercase script. So this script is M, it's the letter M. It is not a point on the line, so be clear that that is not a point. That lowercase script is strictly used to label the line, such as line M. So the takeaways from a line is that you can label it by any 2 points and only 2 points. You can never label it with 3. So label it with 2 points or label it with the lowercase script. And lastly, we're looking at a plane. So a plane is a flat surface. In the video, he explains it multiple different ways. Usually on a typical school year, I explain it as the floor in our classroom. Of course, we can only see the floor in our classroom, but the floor does extend through the walls. So I explain that as a plane and how, we only see a portion of it, but it does go out into the hallways and into other classrooms. The floor continues forever. So when you label a plane, you have 2 different methods to choose from. You can label it by 3 points that are not in a line. So very specific. The points you choose cannot lie in a line. So plane ABC works. If I was to connect them, they clearly do not form a line. Plane CBA works. We could do plane BAC, we could do CAB. There's multiple different ways you can label it using 3 points. Or you can name it by the capital script letter, such as P. P is not a point, P is just used to label the plane. We're going to add a little bit to these by talking about collinear points and coplanar points. So I would describe collinear and coplanar exactly how they sound. Starting with collinear, if something is collinear, that means it's points that are on the same line. So any points on the same line are called collinear. Just think about that first term, co. If it's collinear, multiple points on the same line. Same thing with coplanar. If you have points that are coplanar, it's points that lie in the same plane. And while I'm only going over these 2 words, you could extend this idea to multiple different topics. You could say that you have coplanar lines. So coplanar lines means lines that lie in the same plane. You can extend the start of co to multiple different terms, and it should explain itself. Moving on to the first set of examples. In the first set of examples, we are going to be using this model over here to answer all parts. The first question says to name a line that contains point D. I'm going to highlight point D. Point D is located in the plane where I labeled it in orange. So if we're naming a line that contains that point, you can name it any way, any way as long as you're using 2 points to label the line. So pick one other point. I'm going to pick point E. It's the closest one to it. Clearly, the line intersects both D and E, so I can label that line as line DE. And don't forget to put the correct symbol above the top. It's a line with an arrow in both directions. Okay, this line here, line DE, also intersects the point F. So if you want to label a few other ways, I'm not going to do them all, but a few other ways could be DF with a line over the top. We could label this line EF. Line EF still contains point D. I know we didn't label it in this description, but it still does contain this point. Check out this little script letter. That's a letter L. So we could also say this is line and then a script L, line L. This is just 4 different ways, but this list would continue if you want to. You could continue labeling multiple different ways that, or multiple different lines that include point D. If you wanted to get or think outside of the box, a line is formed by connecting 2 points. So you could connect point D and G, even though you don't see this line there, you could connect them and you could label it line DG if you want. Connect any 2 points and you have a line. Number 2 says name a plane containing point E. Well, here's point E. So if you think of this gray shaded area here as a piece of paper, you want to think what other points are on that piece of paper. So I see other points such as point G, point D, and point F. Those are the only other points I see that are on that piece of paper. It looks like point H is above, and that would be it. So point H is the only point not on that plane. When I label the plane containing point E, we could label it numerous different ways, but I'm going to start by labeling it plane DEG. We could label it plane FEG. We could also label it as plane with the script letter R, plane R. And this list would continue. The only thing you have to be careful with when you're labeling a plane is that the points do not lie in a line. You cannot use 3 points that are lying in a straight line. For example, you could not label this with the points D, E, and F because they fall in a straight line. So 3 non-collinear points. Next, we're labeling 3 collinear points. There's only one line that contains 3 points, and it's line DE. So 3 collinear points would be points D, E, and F. Okay, the order wouldn't matter, but those are the points. Name 4 coplanar points. Coplanar points are points that lie on the same plane. The gray shaded region is our plane. So 4 points that lie on that plane could be point G, D, E, and F. Make sure you specifically label the points. Do not choose the script letters. Script letters are not points. And for number 5, the question asks, is point H on plane R? Here's point H. Point H to me looks like it is above plane R. So if you were thinking about this plane, like in your head, you were trying to visualize it. Visualize a piece of paper that you stick your pencil through. The piece of paper has all the points labeled on it. The piece of paper has points G, D, E, and F labeled. The pencil is sticking straight through the paper, and imagine that point H was the eraser cap on your pencil. So that eraser cap is not on the piece of paper. The piece of paper is in the middle, you stuck your pencil through it. So that's one way to visualize where point H is. Okay, if I was to draw this as a side angle, this would be your plane, your piece of paper, and your pencil is sticking through here. Okay, you have all of your points on this plane, but you have point H up here at the top. So point H is not on plane R. Okay, point H is above it. Another visual method you could think of is thinking of the floor of your classroom or the classroom. You have all the points on the floor, but point H is on the ceiling, so not on the same plane. Planes are a flat surface. They are two-dimensional. Okay, next we're going to talk about intersections, so intersections of lines or intersections of planes. So the intersection of two or more geometric figures is the set of points they have in common. And I'm going to add a couple notes to this box. So the first note that I'm going to add is going to say that two lines intersect in a point. And for example, I'm going to use this one. So we have line L and line M. They intersect at point P. The next note I'm going to add says that lines can intersect planes and planes can intersect each other. So for example, line R intersects plane A, if you want to look at it like that. Or you could say, I'm sorry, I said that. Let me back up. Line R intersects plane A and plane B. You could also say that plane B intersects plane A. So there's multiple ways to look at how planes are intersected. You can either look at it as planes are intersecting each other, or you can look at it as a line is intersecting the planes. If I go back to my visual example, imagine that you're standing in the classroom and the floor, the ceiling, and all of the walls represent a different plane. Where the floor and one of the walls come together, they form a seam along the bottom of the floor, obviously, where they come together. That could be your intersection point. So that seam, the floor seam where the wall and the floor come together, is an example of an intersection of two planes. For the next example section, we're going to go through some true or false problems. If it's true, we leave it alone. If it's false, we need to fix the statement in some way to make it true. For all of these examples, we're using this model. Okay, if I was looking at this model in a different direction, I could see this as my top plane. So let me use my highlighter for this. Here's this plane, highlighted in orange. Then we have this plane highlighted in green. If I was to draw this two-dimensional for you, here's plane GEF. Here is plane ABC. Here is the line that intersects the two of them. So from this model, you should be able to see that point H is up here. You have a bunch of points on your plane that I highlighted in orange. You have a bunch of points that are on the plane I highlighted in green. But from this model, you should be able to see that the orange points and the green points are on different planes, as well as point H. Okay, number one. Points A, B, and C are collinear. Here's A, here's B, here's C. Well, A and B are collinear because they are on the same line, but C is not. So this is false. If I wanted to make it true, I'm just going to cross off and C. Points A and B are collinear. For number 2, it says points A, B, and C are coplanar. A, B, and C all fall on my green highlighted plane, so I would say that is true. Number 3, point F lies on line DE. Here's line DE. Here's point F. Point F lies on that line, so number 3 is true. Number 4, you can name one of the planes as DEF. Here's D, here's E, here's F. That is false. You cannot name a plane as that because D, E, and F are on the same line. If we were to fix this, we could rename the plane. We could name it DEG or FEG or GED, however you label it, but 3 non-collinear points. Number 5, point C lies on line AB. Here's line AB, here's point C. That is not true. So we're going to say that's false. If we wanted to make number 5 true, we could change it and say point C lies on plane ABC. Number 6, point E is the intersection of line DF and GE. Here's line DF, here's line GE. They intersect at this point right here, which is in fact point E. So that is true. And for number 7, line HB is the intersection of planes DGF and ABC. So if we look at this model, my 2 planes never intersect. So line HB does intersect both of them, but the planes themselves do not intersect. So be very clear as to what your intersection point is. The planes do not intersect. So you could change this if you want, and you could say HB. Let's see how I could word this. If I wanted to rewrite something, I could say HB intersects plane DGF at point E. So I could specifically look at just one plane, and I could indicate where this line here intersects this plane in orange, and it's at one point. Or I could indicate where it intersects the other plane, but it does not intersect, or it is not the intersection point of the 2 planes. So number 7 is a little bit difficult, but make sure you think about something like this. So think about the model as a 2-dimensional model. All right, there's an on your own section, which I ask that you complete on your own. So press pause on your video and do your best to complete these. You'll see me put my answers up here in just a moment, but you should be doing them by yourself. The next example set is when we're looking at what we can see here as a cube, and we're answering very similar questions to what we did before, but now we're just looking at this three-dimensional object. Okay, we could think of that cube as our classroom, and that way I can refer to the planes as the floor here, the ceiling here, and then you have the four walls of the classroom. So number one asks you how many planes appear to be in this figure. Well, think about your classroom, you have or your room. You have your floor, your ceiling, and you have four walls. So that's 6 planes total. And I'm just going to write in parentheses, this is all sides. Number 2 says to name the intersection of plane ADC. That would be this plane here, with the plane BFG. BFG, that's this plane here. So I'm just highlighting by connecting the points that I first highlighted, and I can clearly see that these two planes intersect in this line, which would be line BC. Remember that you're labeling it as a line, so it extends in both directions. Number 3 says, at what point do line AD and DH intersect? Here's AD, here's DH. So where do those 2 points intersect? I would say they intersect right here at point D. Number 4, are points A, B, F, and E coplanar? Well, let's highlight them. We have A, we have B, we have F, and we have E. If I was to highlight these, they could be coplanar. If you think about a classroom or a room, it could be the 4 corners of that wall. So I will say yes, these are coplanar. At what point or in what line do planes HGC, BCG, and HEF intersect? All right, let's do some highlighting. Plane HGC, HGC, that's this back plane here. So maybe the back wall. Switch to green. Plane BCG, BCG, that's this side plane here. Okay, and lastly, we're going to look at plane HEF. HEF, that's the top of this figure. So where do they intersect? Well, it looks like all 3 of them only come together in one point, which would be right here at point G. All right, of course, there's sides where 2 of the planes intersect, but there's only one point where all of them come together. So think about the ceiling of your room and 2 walls of your room. Where's the only place that all 3 of them touch? And that would be in one corner of the room. So I'm going to say point G. To finish out the notes for today, here's some helpful tips for remembering certain things we went over. So in the first section, it says through any 2 points there is, hopefully you know or could answer this by yourself, but exactly one line. And in this example, line T is the only line that passes through points A and B. Here's your points. So line T passes through those 2 points. For the next section, if 2 lines intersect, they intersect at, or they intersect in, exactly one point. Here's the 2 lines that we have. You can see they intersect here. So line AE and line BD intersect at point C. Next, we're looking down here. If two planes intersect, then they intersect in exactly one line. Plane RST and plane STW intersect in line ST. That would be right here where these two planes intersect. And the last section, through any three non-collinear points, there is exactly one plane. So that's it for the notes today. I do understand that visualizing in geometry is a huge topic or a huge concern for a lot of students, so I'll do my best through videos to try to either reference some visual topics we can think about or find extra videos or graphics to be able to show you. I know doing this via distance learning might not be the most beneficial, but we'll do our best to make everything as positive and as helpful as possible.